The way we view the universe has a profound impact on our understanding of ourselves. Today we see the Earth as a small, fragile globe, orbiting at just the right distance from the Sun for life to flourish. It appears to be the only planet with life in the solar system, and the planets themselves are mere specks in the vacuum of space. Human life seems reduced to insignificance when set against the vast, nearly empty spaces of modern astronomy. But before the modern era, the universe appeared much more comfortable and accommodating. Thus, medieval European cosmology placed the Earth in the center of a small spherical universe surrounded by the abode of God and the elect. In this study, we will explore an early Earth-centered conception of the cosmos from India. This cosmological system is presented in the Bhagavata Purana, or Srimad Bhagavatam, one of India's important sacred texts. We begin with a brief outline of this system. First of all, the Bhagavatam describes innumerable universes. Each one is contained in a spherical shell surrounded by layers of elemental matter that mark the boundary between mundane space and the unlimited spiritual world. The region within the shell is called the Brahmanda, or Brahma egg. It contains an earth disk called Bhumandala that divides it into an upper heavenly half and a subterranean half filled with amniotic water. Although Bhumandala literally means the circle or mandala of the earth, it has little in common with the earth on which we stand. The diameter of Bhumandala is given in the Bhagavatam, and it is about the size of the orbit of Uranus. Bhumandala is divided into a series of geographic features called oceans and islands. But these are geometrically perfect rings of cosmic size with no resemblance to irregular earthly continents. In the center of Bhumandala is the circular island of Jambudvip, with 9 subdivisions called Varshas. These include Bharatavarsha, which can be understood in one sense as India, and in another as the total area inhabited by ordinary human beings. Jambudvip is centered on the geometrically shaped Sumeru mountain, which represents the world axis and is surmounted by the city of Brahma, the universal creator. The Bhagavatam presents astronomy in geographical and mythological language, and the mode of presentation is different from the familiar modern approach. Although the earth disk of Bhumandala may look naively unrealistic, careful study shows that the Bhagavatam uses it to represent at least 4 different reasonable and consistent models. These are 1. A polar projection map of the Earth globe. 2. A map of the solar system. 3. A topographical map of South-Central Asia. 4. A map of the celestial realm of the demigods. There are bound to be contradictions when one structure is used to represent several different things in a composite map. But these do not cause a problem if we understand the underlying intent. We can draw a parallel with medieval paintings portraying several different parts of a story in one composition. This painting shows St. Peter in 3 different parts of a biblical story. Here is a similar painting from India showing 3 different parts of a story about Krishna. Such paintings contain apparent contradictions, such as the images of one character in different places. But a person who understands the storyline will not be disturbed by this. As source material, we will refer to the Bhagavata Purana and to several important commentaries on this text by traditional Indian scholars. We will also refer to the great Indian epic, the Mahabharata, to other sacred texts, including the Vishnu Purana, and to important Indian astronomical works, such as the Surya Siddhanta. Bhumandala as a planisphere. We begin by discussing the interpretation of Bhumandala as a planisphere, a polar projection map of the Earth globe. Each important interpretation of Bhumandala is obtained by focusing on a cluster of Bhumandala features and temporarily ignoring features outside the cluster. In this case, note that the ring-shaped islands and oceans of Bhumandala have widely varying scales as defined in the Bhagavatam. For now, we ignore this. The planisphere interpretation of Bhumandala requires that we give them all equal width. In fact, this is commonly done in diagrams of Bhumandala, such as this one, dating to the early 19th century. Bhumandala with equalized rings can be seen as a stereographic projection of a spherical Earth. Stereographic projection is an ancient method of mapping points on the surface of a sphere to points on a plane. This method can be applied to map a modern Earth globe onto a plane. This flat projection is called a planisphere. Bhumandala can likewise be viewed as a stereographic projection of a globe. Such globes exist in India. Here is one that was probably commissioned by Sawai Jai Singh, Raja of Jaipur, in the early 18th century. In this globe, the land area between the equator and the mountain arc is Bharatavarsha, corresponding to Greater India. India is well represented, but apart from a few references to neighboring places, this globe does not give a realistic map of the Earth. It was clearly intended for astronomical rather than geographical purposes. Here is another globe showing Jambudweep. Note that Jambudweep is mapped into the northern hemisphere on these globes. Although the Bhagavatam does not explicitly describe the Earth as a globe, it does so indirectly. For example, it points out that night prevails diametrically opposite to a point where it is day. Likewise, there is sunset opposite a point where the sun is rising. According to the Bhagavatam, the sun orbits just above Bhumandala on its chariot. Taken literally, the sun's rays should spread out smoothly over the plane of Bhumandala, leaving no points of sunrise or sunset, and no area in total darkness. This seems to contradict the Bhagavatam's statement about day and night at diametrically opposite points. But there is no contradiction if we adopt the planisphere interpretation of Bhumandala. To see this, consider the equator, the Tropic of Cancer, the Tropic of Capricorn, and the sun's path called the ecliptic. These circles are mapped on a globe as we see here. The sun is always directly above some point on the ecliptic, and the globe rotates relative to the sun plus ecliptic once per day. The sun also slowly moves along the ecliptic, making one circuit per year. The seasons result from the sun's northward and southward movement on the tilted ecliptic circle. These four circles project stereographically as shown here. The ecliptic projects onto an off-centered circle in the planisphere map, and the sun's position on this map corresponds to the point on the Earth globe where the sun is at the zenith. The terminator, or boundary between day and night, is a great circle on the globe that is perpendicular to the sun's zenith position. It projects stereographically onto a circular arc on the planisphere that rotates once every 24 hours. At the equinoxes, this arc becomes a straight line. At the solstices, it bends so that the north polar region is illuminated in the northern summer, or in darkness in northern winter. The passage of day and night is described in the Bhagavatam as a straight terminator rotating over a plane map, as we see here. Although this does not make sense in a literal plane, it is realistic in the planisphere model, and thus it adds weight to this model. Here we see the ecliptic and the zodiac projected stereographically onto the Earth map. The sun and zodiac revolve clockwise together once per day, while the sun moves counterclockwise around the zodiac once per year. Here the zodiac is projected stereographically onto Bhumandala. Note that as the Sun goes around the off-centered zodiac in its yearly orbit, it crosses the ring-shaped islands and oceans of Bhumandala. This ocean-crossing motion is described in the Puranas, and this also adds weight to the planisphere model. Bhumandala can be compared with an astronomical instrument called an astrolabe, which was popular in the Middle Ages. On the astrolabe, the off-centered circle represents the orbit of the Sun, the ecliptic. In an astrolabe, the Earth is represented in stereographic projection on a flat plate called the mater. The ecliptic circle and important stars are represented on another plate called the ret. Different planetary orbits could likewise be represented by different plates, and these would be seen projected onto the Earth plate when one looks down on the instrument. The Bhagavatam similarly presents the orbits of the Sun, the Moon, and important stars on a series of planes parallel to Bhumandala. The orbits of the planets are placed on additional parallel planes. Here we see the Bhagavatam's model of the orbits of the Sun, Moon, and 28 important star constellations. These lie in 3 planes parallel to Bhumandala. The layout is comparable to that of an astrolabe. Seen from the side, we find that the Moon is higher than the Sun, but this is simply an artifact of the astrolabe model. It should not be taken as physical. Seen from above, everything falls into place in projection in an astronomically realistic way. Although the Bhagavatam presents the Earth-Moon system indirectly as a planisphere model, the Indian astronomical texts called Jyotisha Shastras directly give a realistic picture of the Earth-Moon relationship. Here we compare the Earth, the Moon, and the lunar orbit in modern astronomy with their counterparts in the Surya Siddhanta, one of the main Jyotisha Shastras. Bhumandala as a map of the solar system. We have shown that Bhumandala and the orbits of the Sun, Moon, and planets have the structure of an astrolabe based on a stereographic projection of the Earth globe. But Bhumandala has another cluster of related features that identify it as a model of the solar system. Consider the plane of Bhumandala cutting across the sphere of the Brahmanda. Previously, we interpreted Bhumandala as a planisphere map, but now we shall take it as a literal plane. When we do this, it looks at first like a naive flat Earth, with the bowl of the sky above and the underworld below. But the Sun doesn't fit the naive flat Earth model. The Bhagavatam says that the Sun orbits on its one-wheeled chariot, which rides on Bhumandala. If we take Bhumandala as a literal plane, we see that the Sun orbits nearly in this plane. This is not what we expect in a naive flat Earth model. There we expect the Sun to rise above the flat Earth disk at a steep angle and then set at a similar angle. The motion of the Sun on its chariot corresponds to what happens in the Arctic during the summer, but it never would be observed at the latitudes of India. At these latitudes, the Sun orbits above an observer's head, as shown in this model. Since Bhumandala is close to the plane of the Sun's orbit, Bhumandala must stand at an angle to the plane of the observer's horizon. It is not the flat Earth imagined by naively extending that horizon. Rather, it can be argued that Bhumandala corresponds to the ecliptic plane. The Sun has 2 motions. In the planisphere model, the rapid daily clockwise motion takes the Sun around the cosmic axis of Meru relative to Bhumandala. The slow yearly counterclockwise motion takes the Sun around the ecliptic circle. Here the predominant motion is clockwise. The Bhagavatam talks about the Sun's clockwise motion, but it also talks about a yearly counterclockwise motion of the Sun relative to Bhumandala, as shown here. This motion supports the interpretation of Bhumandala as the ecliptic plane, since the Sun goes around the ecliptic counterclockwise once per year. The Bhagavatam explicitly recognizes this as a contradiction. It resolves the contradiction by describing the motion of ants on a spinning potter's wheel from different points of view, that of an observer standing beside the wheel and that of an observer standing on the wheel. This is the concept of relative motion, but we must realize that the Bhagavatam uses the same reference frame, namely Bhumandala, to describe different relative motions. The scholars Giorgio del Santillana and Hertha von Deckend carried out an intensive study of myths and traditions and concluded that the so-called flat earth of ancient times originally represented the plane of the ecliptic and not the earth on which we stand. In their model, shown here, the Sun also orbits around the plane of the ecliptic earth. Later on, the original cosmic understanding of the earth was apparently lost, and the earth beneath our feet was taken literally as a flat plate. Here we see an early Greek version of this idea. In India, the earth of the Puranas has often been taken as literally flat. However, the details given in the Bhagavatam indicate that its cosmology is much more sophisticated. It turns out that the disk of Bhumandala corresponds in some detail to the solar system. First of all, the solar system is nearly flat. The Sun, the Moon, and the 5 planets, Mercury through Saturn, all orbit nearly in the ecliptic plane. The Sun, Moon, and planets also orbit very close to one plane in the cosmology of the Bhagavatam. In one verse, the region where the planets orbit is compared to the thin space between 2 halves of a bean seed. The region of the planetary orbits is called antariksha, or inner space. In this picture, it is shown as a thin plate extending directly above Bhumandala. In the planisphere model, the planes of the planetary orbits correspond to the plates in an astrolabe. This is not realistic for a solar system model, but it is realistic to put the planetary orbits in a thin disk of space parallel to the ecliptic. The heights of the planetary orbits are given in a unit called the yojana, which is about 8 miles in length. All distances in the Bhagavatam are expressed in terms of this unit. The thickness of the antariksha disk is roughly the same as the spread of the orbits of Mercury through Saturn perpendicular to the ecliptic. In this picture, both this spread and the thickness of antariksha have been stretched by a factor of 3 for the purpose of easy comparison. In the planisphere model, we ignored the actual size of Bhumandala and compressed its ring-shaped features into a small set of rings around Jambudvip. But if we restore these rings to their real size, we find that they correspond to planetary orbits. First of all, we can understand the size of Bhumandala by comparing it with the orbit of Uranus. Measured in yojanas, Bhumandala is slightly bigger in diameter than the orbit of this planet. Within Bhumandala, a ring-shaped mountain called Loka Loka is defined by the Bhagavatam as the outer limit of the luminaries. Perhaps coincidentally, this ring is about the size of the orbit of Saturn, the outermost of the planets visible to the naked eye. We can understand the scale of Bhumandala by comparing it with the Earth, the solar system out to Saturn and Uranus, and the Milky Way galaxy. Bhumandala closely matches the solar system, but it differs radically in size from the Earth and the galaxy. If we compare the rings of Bhumandala with the orbits of the 5 planets, Mercury through Saturn, we find further alignments which give weight to the hypothesis that Bhumandala was designed as a map of the solar system. To show this accurately, we have to look at a geocentric model of the solar system. Here is the geocentric system as given by the famous astronomer Tycho Brahe. Note that Brahe has the 5 traditional planets orbiting the Sun and the Sun orbiting the Earth. In the 19th century, the South Indian scholar Tiruvenkata Ramanuja Geoswami compared the solar system with Bhumandala. Here is a diagram of his model. Tiruvenkata's model exactly matches the geocentric model of Tycho Brahe. In fact, this is the natural way to compare Bhumandala with the planetary orbits. Planetary orbit can be portrayed from a sun-centered or earth-centered standpoint. Here we see how the orbit of Venus changes when we shift the camera's viewpoint from the Sun to the Earth. The sun-centered viewpoint is essential for modern orbital calculations, but the Earth-centered viewpoint is necessary for all Earth-based observations. In a geocentric model, a planet orbits the Sun, while the Sun orbits the Earth. This produces a looping motion like that produced by a spirograph. In this simple mechanical model, we see the Sun orbiting the Earth in the center, and Venus orbiting the Sun. Here we see the orbital track traced out by Venus in its geocentric orbit. Note that it passes from one boundary circle of Bhumandala to another. Here we see the same thing for Mercury. The alignment between the planetary orbit and the circular features of Bhumandala is approximate at 8 miles per yojana. If we choose about 8.5 miles per yojana, it becomes very accurate for all 5 traditional planets. Here we see the orbit of Mars. This orbital spiral also grazes an inner circle of Bhumandala and an outer circle. The Sun's geocentric orbit is a simple near-circular ellipse that runs down the center of one of the oceans of Bhumandala. It is noteworthy that the geocentric orbit of the Sun is so small compared with the Brahmanda that the Brahmanda is nearly Sun-centered or heliocentric. It is also worth noting that some commentators on the Bhagavatam take it to be fully heliocentric. The inner planets, Mercury, Venus, and Mars, are close neighbors of the Sun. For these planets, there is a 1-to-1 match between the 6 inner and outer boundary curves of their orbits and 6 bounding circles of Saptadweep, the inner system of 7 islands and oceans of Bhumandala. The Sun's orbit provides a 7th circle, dividing the 6 into 2 symmetric groups. The outer planets Jupiter and Saturn delineate a larger ring of Bhumandala lying outside Saptadweep. Jupiter defines the inner boundary of this ring, and Saturn nearly grazes its outer boundary, known as Lokaloka Mountain. As we mentioned before, this ring mountain is fixed in the Bhagavatam as the outer boundary of the luminaries, and Saturn is the outermost planet visible to the naked eye. Until recent times, astronomers generally underestimated the distance from the Earth to the Sun. Thus it is remarkable that the dimensions of Bhumandala in the Bhagavatam are consistent with modern data on the size of the Sun's orbit and the solar system as a whole. In particular, the Earth-Sun distance and the size of the solar system were seriously underestimated by Claudius Ptolemy, the greatest astronomer of classical antiquity. The detailed correlations between Bhumandala features and planetary orbits may seem contrary to the known history of science, but they are corroborated by historical data suggesting the existence of advanced scientific knowledge in the distant past. For example, a historical study of the yojana provides evidence supporting a yojana length of about 8.5 miles, the same length that emerges from the comparison of planetary orbits with Bhumandala. This yojana length is connected with accurate knowledge of the degree of latitude, and this requires accurate knowledge of the size and shape of the Earth. The historical evidence for the size of the yojana involves Greek and Chinese reports on distance measurements in India. It ties in with extensive evidence for the existence of scientifically defined measures in ancient Egypt and the Near East. And it is corroborated by the unit of measure called the hat that was used in the design of the 12th century temple of Angkor Wat in Cambodia. The orbital correlations are also supported by a statistical study reported in the text. Taking all of the evidence into account, the remarkable agreement between the solar system and the detailed structure of Bhumandala cannot be dismissed as a mere coincidence. Jambudweep is a topographical map of South-Central Asia. Jambudweep, the central hub of Bhumandala, can be understood as a local topographical map of part of South-Central Asia. This is the third of our 4 interpretations of Bhumandala. In the planisphere interpretation, Jambudweep represents the northern hemisphere of the Earth globe. However, the detailed geographic features of Jambudweep do not match the geography of the northern hemisphere. Consider this map of Jambudweep. The circle of Jambudweep is divided into 9 regions called Varshas by 6 horizontal and 2 vertical mountain chains. The southernmost region is called Bharata Varsha. Careful study shows that this map corresponds to India plus adjoining areas of South-Central Asia. The first step in making this identification is to observe that the Bhagavatam assigns many rivers in India to Bharat Varsha, the southernmost division of Jambudweep. Thus Bharat Varsha represents India. The same can be said for many mountains in Bharat Varsha. In particular, the Bhagavatam places the Himalayas to the north of Bharat Varsha in Jambudweep. A detailed study of the Puranic accounts allows the other mountain ranges of Jambudweep to be identified with mountain ranges in the region north of India. Although this region includes some of the most desolate and mountainous country in the world, it was nonetheless important in ancient times. For example, the famous Silk Road passes through this region. The Pamir Mountains can be identified with Mount Meru in Ilavrita Varsha, the square region in the center of Jambudweep. Note that Mount Meru does not represent the polar axis in this interpretation. Cosmology and earthly geography. There are many cosmological traditions around the world which share important features of Bhagavata cosmology. These include a cosmic axial mountain or pillar, which is often identified with a local mountain, such as Mount Olympus in Greece. These traditions also include other standard features, including those shown in this generic world model. The cosmology of the Bhagavatam and the Puranas is shared in its broad features by Buddhism, and it is widespread in the Buddhist countries of Asia. This East Asian picture depicts a square version of Mount Meru and the oceans and islands of Bhumandala, surmounted by planetary orbits. This Korean wheel map shows a central continent surrounded by a circular ocean and another circular continent. Joseph Needham, in his treatise on Chinese science, traces these wheel maps to India or Babylon. Here is a Babylonian wheel map. Wheel maps were also made in medieval Europe. In these Judeo-Christian maps, Jerusalem and the sacred hill called Mount Zion were identified as the world axis. Somehow or other, the tradition of Jambudweep seems to have influenced Gerardus Mercator, who placed a mountain surrounded by a circular continent at the north pole of his map of the Arctic region. The 4 perpendicular rivers or channels flowing from the central mountain correspond to the 4 branches of the celestial Ganges flowing from Mount Meru. Here is a Phoenician seal with a personified world mountain and 4 streams issuing forth at right angles. The Dogon tribe, living near the upper bend of the Niger River, posit a circular continent with a central pillar surmounted by the residence of their high god Amma. Note the world-girdling serpent in the circular ocean. The ethnologist Evans Wentz identifies this Navajo sand painting as a representation of the 4 sacred directional mountains of the Navajos. In many traditions, the world mountain is surrounded by 4 mountains in the cardinal directions, and we also see this in the Bhagavatam and other Puranas. The color scheme is similar to that found in Puranic and Buddhist traditions. The 4 directional mountains of Jambudweep have 4 sacred trees on their summits. These include the Jambu tree, after which Jambudweep is named. The theme of a cosmic tree of life is very common, and this tree often grows on the world mountain or stands in place of it. Here we see the Scandinavian tree of life called Yggdrasil. The apocryphal biblical literature describes a tree of life with 4 rivers of honey, milk, oil, and wine that flow down into Eden. For comparison, the Bhagavatam has rivers of special juices flowing from its 4 sacred trees. This Assyrian seal shows the tree of life on the world mountain, plus 2 sacred streams. In this East Asian picture, the tree of life stands upon the column of Mount Meru, centered on the ring pattern of Bhumandala. The Mayans of Central America have a tree of life that extends through 7 heavens, and they also speak of 5 lower worlds. Graded heavens and underworlds are found in many cosmologies, including that of the Bhagavatam. Here we see the cosmology of the Shipibo tribe of the Peruvian Manteya. This includes the tree of life, the circular continent and surrounding ocean, and the world-girdling serpent. The cosmology of the Warao of the Orinoco Delta also features a serpent of being that surrounds their world. Here we see the Norse serpent that surrounds Midgard, the inhabited world of Norse cosmology. The Bhagavatam places a universal serpent called Anantashesha beneath Bhumandala. He is generally depicted as supporting the earth from beneath, but the Mahabharata also says that he encircles her in his coils. The Bhagavatam places the cities of Brahma and the 8 Lokapalas on top of Mount Meru. Similarly, many traditions place the abode of the gods on top of their axial mountain or pillar. Here is the geometric layout of the cities of the 8 Lokapalas, or world guardians. These figure in the Vastu Purusha Mandala used to lay out temples in traditional Indian architecture. The grid of the Vastu Purusha Mandala is also associated with the nakshatra constellations marking the ecliptic. Thus the earthly side of a temple was connected with the heavenly realm of the ecliptic. This brings us back to our interpretation of Bhumandala, the circle of the earth, with the solar system. In India, it was traditional to identify the earth, or a localized part of the earth, with the heavens. We see the same thing in many traditions where the cosmic axis is identified with a mountain or cultural center. Bhumandala as a map of the celestial realm of the demigods. Bhumandala can also be understood as a map of the celestial realm of the demigods. One curious feature of Jambudweep is that the Bhagavatam describes all of the Varshas, or regions, other than Bharata Varsha, as heavenly realms, where the inhabitants live for 10,000 years without suffering. This has led some scholars to suppose that Indians used to imagine foreign lands as celestial paradises. However, the Bhagavatam does refer to barbaric peoples outside India, such as Huns, Greeks, Turks, and Mongolians, who are hardly thought to live in paradise. One way around this is to suppose that Bharata Varsha includes the entire Earth globe, while the other 8 Varshas refer to celestial realms outside the Earth. This is a common understanding in India, and it is illustrated by this 19th century South Indian diagram, where the Earth globe is identified with Bharat Varsha. But the simplest explanation of the heavenly features of Jambudvip is that Bhumandala was intended to represent the realm of the demigods. Like the other interpretations we have considered, this one is based on a cluster of mutually consistent points in the cosmology of the Bhagavatam. The first point is that the demigods are portrayed as being so large that we are literally like ants in comparison with them. For example, this picture shows the size of Lord Shiva in relation to Europe, based on dimensions given in the Bhagavatam. This explains the enormous sizes attributed to mountains, trees, and other features in Jambudvip. Although Jambudvip refers to a region of this earth, it doubles as a realm of demigods of superhuman size. How can mere humans meet and interact with such gigantic beings? The answer is that travel from this earth to the celestial realm may involve a great expansion in size. For example, in the Bhagavatam story of Matsya Avatar, King Satyavrata of South India finds a remarkable fish. Later on, the fish expands to 8 million miles in length and pulls the king on a boat through a cosmic deluge covering Bhumandala. Systematic changes in size are carried out using the siddhis, or mystic powers, called anima, size reduction, and mahima, size expansion. According to the Bhagavatam, these powers are based on the transcendental form of Vishnu, who is larger than the universes as Mahavishnu, and smaller than an atom as the Supersoul. There are also siddhis which enable one to take shortcuts across space. This is illustrated by a story from the Bhagavatam in which the mystic yogini Chitralekha abducts Aniruddha from his bed in Dwarka and transports him mystically to a distant city. In addition to moving from one place to another in ordinary space, the mystic cities enable one to travel in the all-pervading ether or to enter another continuum. A classical example of a parallel continuum is Krishna's transcendental realm of Vrindavan, which is said to be unlimitedly expansive. This transcendental realm is said to exist in parallel to the finite earthly Vrindavan in India. A story from about 500 years ago tells of how Dukhi Krishnadas found an ankle ornament belonging to Radharani that fell into this dimension from the transcendental Vrindavan. He subsequently met a gopi who came from that realm to retrieve the ornament. Later on, Dukhi Krishnadas, who is now known as Shaimananda, entered the same transcendental realm in meditation. Thus the transfer from one continuum to another depends on the traveler's state of consciousness. The Sanskrit literature abounds with stories of parallel worlds. For example, the Mahabharata tells the story of how Arjuna was abducted by the Naga princess Ulupi while bathing in the Ganges. Arjuna was pulled down into the kingdom of the Nagas, which exists in another dimension. The idea of parallel worlds linked by mystical travel explains how the worlds of the demigods and still higher beings are connected with our world. In particular, it explains how Jambudvip, as the celestial realm of the demigods, is connected with Jambudvip as the earth, or part of the earth. The vertical dimension in Bhagavad Cosmology. The Bhumandala disk represents the exoteric domains of the earth and planets. In contrast, the cosmic axis, extending perpendicular to Bhumandala, is filled with esoteric meaning. It represents the path of ascent or descent of the soul. In addition to the orbits of the sun, moon, and planets, there are different worlds or lokas arrayed above Bhumandala along the cosmic axis. These upper worlds can be entered through mystic cities, and they are accessible only to persons of advanced spiritual consciousness. For example, Maharloka or Rishi Loka is the world of the sages. It is said that in this world, Lord Vishnu directly appears before his devotees and receives the offerings of fire sacrifices in his hands. The first three upper worlds are Bhumandala itself, Bhuvarloka, or Antariksha, where the planets orbit, and Svargaloka. In the vertical direction, these worlds are closely spaced, as we have seen before. Below the level of the sun in Antariksha lie Rahu, the abodes of the Siddhas and Charanas, and the abodes of Rakshasas and different types of evil spirits. The Bhagavatam places the latter abode directly above the atmosphere, and it does in fact lie somewhat above the upper reaches of the atmosphere as we understand it today. Beneath Bhumandala are 7 lower worlds, described as chasms within the earth. Since life there is filled with heavenly opulence, they are called Bila Svarga, or subterranean heavens. In Jyotisha Shastras such as Surya Siddhanta, these lower worlds are described as caverns within the concave strata of the earth globe. Chinese traditions speak of cave heavens, where a man may be seduced by beautiful women in an opulent setting. In one Chinese story, a person returning from one of these caves finds that generations have unexpectedly passed. This theme of missing time is found all over the world in stories of parallel worlds. The Bhagavatam tells a similar story of a lower world called Atala, where beautiful women will entice and exploit any man who enters. Beneath Bhumandala in its lower strata, there is the Garbhodak ocean with Anantashesha and Garbhodakashayi Vishnu. These divine incarnations are said to be inaccessible to persons who lack the qualifications to see them. The Garbhodak or amniotic ocean fills the lower half of the sphere of the Brahmanda. If we interpret Bhumandala as the ecliptic plane, then this ocean must lie in all directions in the sky to the south of the ecliptic. Between the Garbhodak ocean and Bhumandala are located the hellish worlds and Pitriloka, the realm of the ancestral spirits. The Vishnu Purana describes a path through the sky to Pitriloka. This starts just below the ecliptic, near the constellations Scorpio and Sagittarius, and it extends southward to the star Canopus, known as Agastya in Sanskrit. There is likewise a path of the gods, which extends north of the ecliptic to the constellation of the 7 sages, which we know as the Big Dipper. From there, liberated souls reach the abode of Vishnu in Dhruvaloka, the pole star. The Bhagavatam describes the vertical dimension of the Brahmanda as a universal form of God, extending from the lowest world at the soles of the feet to the highest at the crown of the head. In this traditional picture, we see the rings of Bhumandala forming the belt of the universal form. Here the positions of the worlds are indicated in relation to the universal form. The levels in the universal form are associated with the spinal chakras on which yogis meditate, and the spine itself is called Meru Danda, after Mount Meru, the cosmic axis. The ascent of the soul through different levels of the Brahmanda is analogous to the ascent of the life force through the chakras in the body. In general, the vertical dimension of the universe represents the path of ascent or descent of the soul through different worlds in different states of consciousness. It lies perpendicular to the plane of Bhumandala, which is the world of the planetary orbits. The greater universe. In pre-modern cosmology, the stars were generally treated as small nearby objects, shining with the reflected light of the sun. The same perspective is there in the Bhagavatam and other Puranas, but a few observations should be made to place this in its proper perspective. In this medieval European diagram, the stars are indicated by the signs of the zodiac, arranged around the boundary of the planetary system. These signs serve as divisions of the ecliptic, marking the movements of the planets. The Bhagavatam similarly places 28 constellations called nakshatras in a plane just above the moon. The moon completes one orbit in 27 1/3 days, and the nakshatras mark its day-by-day motion around the ecliptic. This makes sense in the planisphere interpretation, where the nakshatras serve as a clock face, and the sun, moon, and planets are like the hands of the clock. In addition to the 28 nakshatras, the Bhagavatam mentions a few other stars, such as the 7 sages defining the Big Dipper. These stars are also placed close to the plane of Bhumandala, and their function is to mark the turning of the Kala Chakra, the wheel of time. The pole star Dhruvaloka is mentioned as the fixed center of the time wheel, and is placed directly above the 7 sages. It is regarded as the abode of Vishnu, who controls time while remaining outside of time. The Bhagavatam therefore stresses that Dhruvaloka is fixed on the polar axis, and thus it does not recognize the precession of the equinoxes. According to modern calculations, Polaris is near the North Pole now, but for many centuries there has been no good pole star. The last prominent star to come close to the pole was Thuban, Alpha Draconis, which served as the pole star in about 2500 BC. It may be that the widespread idea of the pole star in old traditions refers back to this time. Although the Puranas generally place the stars nearby, we do find indications in ancient Sanskrit literature that the region of the stars is far away, so far that the sun and moon cannot be seen from there. For example, the Mahabharata tells how the hero Arjuna traveled to the region of the stars, which he saw as large, self-luminous spheres, unaccompanied by the sun or the moon. This account is supported by the Jyotisha Shastras, Surya Siddhanta and Siddhanta Shiromani, which greatly enlarge the Puranic estimate of the Brahmanda's diameter. Their estimate of this diameter comes to 10,000 light-years, or about 1/10 the size of the Milky Way galaxy. The Bhagavatam in its commentaries state that the Brahmanda is surrounded by 7 spherical layers of elemental matter, as given by the Sankhya philosophy. Each successive layer is said to be 10 times as thick as the one preceding it. Innumerable Brahmandas, each surrounded by its elemental layers, are said to be floating within the causal ocean in the unlimited spiritual world. Thus the Bhagavatam places the Brahma egg in the context of a multiplicity of worlds, occupying an unlimited continuum of space. In summary, the cosmology of the Bhagavat Purana is a sophisticated system of